Hello everyone, welcome back to the 10 days of JavaScript. Here we are in day number 9, and in this lesson we are going to learn about 5 or 6 different topics that are all important, but maybe each one didn't deserve its own standalone dedicated lesson. Okay, now without further ado, let's jump into the first topic, and that is anonymous functions. So what in the world is an anonymous function? Well, throughout this course, usually when we create a function, we give it a name, right? So we would say function and then my cool function, parentheses, curly brackets. Well, as the name suggests, an anonymous function would simply be if we got rid of the name, right? So if we just had this. Now, at first glance, you might think, well, what is the point of this? If it doesn't have a name, how can we ever call or execute it later on in our code? Well, let me show you an example of when we could use an anonymous function. So let's erase this and let's give ourselves a goal. Let's imagine that we want to set things up so that whenever the user clicks anywhere on the web page, so anywhere down here, whenever they click, we want to show an annoying alert pop-up message that says, "Thank you for clicking." Now we've already done this in an earlier lesson, but this time I want to show you how we can use an anonymous function. So because we are speaking JavaScript in the web browser environment, we have access to the document object, and we can look inside it and call the add event listener method. And then remember, we give this method 2 arguments. The first is the event that we want to look out for, in this case, click. And then the second argument is a function that this method will call at the appropriate time. Now, up until this point in the course, we've always included the name of a function here, and then maybe created that function with the matching name down here. And that's a great approach if you think there's even a 1% chance that you would ever need to call or use that function somewhere else in your code besides just this line. But what if we're pretty darn confident that this is the only place where we would need to use the function? Well, in that case, we can actually just include an anonymous function right here for the second argument. Or in other words, instead of just the name of a function here, we can actually include the recipe for the function itself. So check this out. We can get rid of b and say function, parentheses, curly brackets, and we could even drop down in between the curly brackets like normal. And remember, our goal was to create an alert pop-up message. So alert, and have it say, "Thank you for clicking." Okay, now if I come down to the preview part of the web page and click anywhere in here, awesome. We can see that that function successfully executed. Now again, because this is an anonymous function, it has no name, so we have no way of referencing it or calling it anywhere else in our code. But that's not a bad thing if we don't need to call it anywhere else. Okay, now let's change gears. We've seen anonymous functions in a nutshell. Now the next topic I want to talk about in this lesson is arrow functions. So what in the world is an arrow function? An arrow function is a special type of function that uses an alternate syntax, or we could say a cleaner or more minimalistic syntax. And it also has a few other key differences from a traditional function like this. But first, let's start with the syntax of an arrow function. So check this out. It's very easy to convert this traditional function into an arrow function. We begin by removing the word function, but keeping the parentheses right after it. So literally, let's just get rid of the word function here. Okay, now in between the parentheses and the curly brackets, we include an arrow symbol, which is really just an equal sign and then a greater than sign smooshed together. And that's all we need to do. So congratulations, you just created your first arrow function. We can test it out. If we come down to the preview area and click, awesome. Now, believe it or not, but we can actually make the syntax for an arrow function even cleaner or even more minimalistic. So let's do this. Inside the curly brackets for our function, let's not jump down to a new line like we usually do. So I want to place my cursor right at the beginning of alert and just hit backspace a few times. And then down at the beginning of this line, we can backspace to put it all up on a single line. And now with an arrow function, if the body of your function sits on a single line, we actually do not need the curly brackets surrounding the body. So we can get rid of this opening curly bracket here and get rid of the closing curly bracket right here. And if we test out our code and click down here, we see that it works just the same. So an arrow function really lets our code be a bit cleaner. Now, before we move on to the next topic, there are two more features of the arrow function that I want to show to you. The first feature is that when the body of our function sits on a single line like this, the arrow function is automatically going to return whatever we include here. Now, in this case, we don't need to return the alert message, but in the case where you do want to return a value, this can save us even further typing and let our code be even more minimalistic. Let me show you what I mean. So let's get rid of this example, and let's imagine we have an array. Let's call it my numbers. And let's just set the array to hold a few values like 10, 500, and 2000. Okay, now let's imagine we want to use the map method to create a brand new array where each item from this array has been doubled. So we could create a new variable to store the new array. We could call it doubled numbers and set it to equal the original array, my numbers, and then call the map method. And now practice makes perfect, so let's do this. Within these parentheses, let's first include an anonymous function that's just a traditional function, and then we can practice converting it into an arrow function. So for an anonymous function, I would spell out the word function, and then parentheses, curly brackets. We know that each time the map method calls our function, it's going to pass into it whichever item from the array it is looped to. So within our function parentheses, we want to include a parameter to work with the current item. And then in the body of our function, we would just return that number or that parameter times 2 to double it. So now let's test this out. Let's log out to the console, our new array. So console.log doubled numbers. And if we check the console, cool. We see that the numbers from the original array were successfully doubled. Now let's make it our goal to turn this into an arrow function. So first we just get rid of the word function, but we keep the parentheses with our parameter. Then in between the parentheses and the curly brackets, we include an arrow symbol, which is just equal sign and then greater than. Okay, and then let's adjust it so that the body of the function sits on the same line. Backspace here and backspace down here. If it sits on a single line, we don't need the curly brackets. Also, if it sits on a single line, we do not need to include the word return here. Return is just sort of implied in this sense, so we can actually get rid of that. And another tip to clean up our code, we do not need the parentheses around our parameter if it's just one single parameter. We only need the parentheses if we have 0 parameters, or if we had multiple parameters. If you just have one though, we can actually get rid of these surrounding parentheses like this. Now at first, this syntax looks really weird because it's not what we've practiced throughout the course. However, as we can see, it has the potential to really clean up our code. Instead of having a separate function down here with the word function and a function name and parentheses and curly brackets and the word return, we literally just have these few characters. Cool. Now there's just one more feature of the arrow function that I want to show you before we move on to the next topic in the lesson. And you do not need to type this out with me. You can just watch. So I'm going to delete what we have here and actually just paste in my clipboard. And this example should look familiar from our previous lesson. Remember, this is the code we had when we were learning about context and the this keyword. And right now, I want us to focus on this inner function. Because remember, in this context, the this keyword is pointing towards the global object, instead of the John object. And this behavior of JavaScript can be confusing, it can seem unintuitive, but that's just the way it is. When we call a function that doesn't belong to an object, or I should say when we call a function that isn't a method, JavaScript considers the object that is calling or executing that function to be the environment's global object. So that's just review. We learned that in the previous lesson. Now the question is, what if within this function, we really wanted the this keyword to point towards John? Well, we have a few different options. We could use the call method that we learned about in our previous lesson, but remember the topic at hand right now is arrow functions. So the final feature of arrow functions that I want to talk about is that they do not have their own new this keyword. So if for whatever reason we really wanted to break our code up into an inner function like this, and we really wanted the this keyword to still point towards the John object, we could just use an arrow function. So I'm going to get rid of this entire function declaration right here. I'm going to keep the call to the function, but I will get rid of the function declaration, and we instead could create a variable, call it I'm a function, not a method, and set that variable to equal an arrow function. And just as a test, I will log out to the console, the this keyword inside of this function. Okay, and we're still calling it just like a regular old function, but if I check the console, right above John Doe is driving a car, we see that the this keyword is pointing towards our John object instead of the global object. Awesome. The reason this happens is because arrow functions do not have their own new this keyword the way that a regular traditional function does. And arrow functions use the same variable lookup strategy that we learned about in the previous lesson with scope. So JavaScript's going to say, okay, does the this keyword exist within this current local scope or within the body of this function? No, it doesn't. So I'm going to look one level up or one level outside of this, which would be the block for our drive car method, right? And we know that inside that, like where the cursor is right now, we know that the this keyword does exist, and it's pointing towards exactly what we would expect it to point towards, the John object. So long story short, I know that was a bit of a ramble, but this can be a really confusing topic, so I wanted to go over it in slow motion. Long story short, a simpler way of wording this is that arrow functions do not change the value of the this keyword. Whatever the this keyword was pointing towards in your current context, that's still what it's going to be pointing towards even inside of your function. And this makes arrow functions a really nice tool to have up our sleeve. Okay, so that's arrow functions in a nutshell. Now let's move on to the next topic in this lesson, which is function hoisting. Let me delete all of this code. And what in the world is function hoisting? Well, let me show you an example. Let's imagine we have a function named cool, and maybe it just logs out to the console a bit of text that says, this is super cool. Okay, now imagine right above this function declaration, so up on the very first line, I try to call the function. If I check the console, we see this is super cool. So our code is working successfully. However, the only reason this code works is because of function hoisting. What I mean by this is usually the ordering of our lines matters in JavaScript, right? Like if down here, I created a variable called strawberry count and set it to 100, I can only access the strawberry count variable below this line of code, right? I can't expect to be able to access strawberry count before it's been created. So if above this line, I tried to log out to the console strawberry count and then try to check the console, we see uncaught reference error, strawberry count is not defined. So clearly the ordering of our lines matters. So the question is, why are we able to call this function before we've even created the function? Well, the answer is because JavaScript has something called function hoisting. As far as JavaScript is concerned, this section of code might as well be up at the very, very, very top of our code. Hence the name hoisting, right? We can consider this code hoisted or moved up to the very top, even though it's not there physically in our code. However, not all functions get hoisted. So yes, a function declaration like this will be hoisted. A function declaration is where we actually use the keyword function and give it a name. But we know that there are other ways to create a function. So check this out. What if instead we create a variable and call it cool and set it to equal an anonymous function, right? So function parentheses curly brackets, and then we try to log out to the console and say, hey. Well, if we check the console, we just see uncaught reference error, cool is not defined. So just be aware that unless you create a function with the actual keyword function and then the name, your function is not going to get hoisted. So in this case, with this example, we would need to call the function below where we are creating the function, like this. Now it works just fine. So big picture, with a traditional function declaration, you can get a bit lazy with the ordering of your lines, but if you create a function in any other fashion, you need to pay attention to your line order. Okay, now let's change gears. So that was function hoisting in a nutshell. Let's move on to the next topic in this lesson, which is template literals. So what in the world is a template literal? Well, I'm going to delete this code and start fresh. So let's imagine we have a variable called my name, and we set it to equal whatever your name is. And then imagine we want to log out to the console a bit of text that says, hello, my name is blank, right? And then it pulls in the variable. And then we also add on, and the sky is blue. Right, so if we check the console all together, we see that that pulls in the value for the my name variable. So our code is working as we would expect, but this syntax can be really awkward. I'm sure if you're being honest, there was a point throughout the course so far where you got frustrated with the having to open up a quote and then close the quote and then plus symbol, variable, plus symbol, new quotes. It just gets awkward to type and it's not ideal. So right now I want to show you a new tool called a template literal, which is going to make our life a lot easier. So let's get rid of this entire string of text and instead use two backticks. This character is directly to the left of the 1 key or right above the tab key. So instead of a string of text, we would call backticks like this a template literal. But really, we can just think of it as a string of text with superpowers. So check this out. We can just say, hello, my name is blank and the sky is blue. Now obviously we don't actually want the word blank here. We want to do something dynamic. We want to include an expression, or we should say we want to pull in the value of this variable. So within a template literal, when you want to do something dynamic, you just include $, curly brackets, and inside here we can include an expression. Or I should say we can do something dynamic. So instead of just a string of text that's going to be interpreted literally, we could say 2 plus 2, and this would say, hello, my name is 4. Or what we really want to do is just pull in the variable. Awesome, so that gets the job done, and in my opinion, this is so much easier to type out and work with. We don't have to use the plus symbol, and we don't have to keep dropping in and out of the quotations. When you want to do something dynamic, you just say $, curly brackets. And remember, to create a template literal, where we have this superpower, we just wrap our text within backticks instead of regular quotes. Okay, so that's template literals in a nutshell. Now let's move on to the final topic in this lesson, and that is semicolons. So let's give ourselves a goal. What if we wanted these 2 lines of code here to be squished together and just sit on a single line of code that's really long? So we could just delete the white space like this. But this is not valid JavaScript. This is throwing an error. JavaScript cannot make sense of what we are trying to do here. However, where my cursor is right now, if we just place a semicolon, everything's fine. This is perfectly valid JavaScript code. So the idea is that a semicolon is sort of the period at the end of a JavaScript sentence. It's our way of taking a breath or letting JavaScript know that this thought is complete. Now here's the interesting part. Without the semicolon here, the code breaks. It doesn't make any sense. But if we just drop down to a new line, everything is fine. This code will run perfectly. This is because the JavaScript language has something called automatic semicolon insertion, meaning behind the scenes, JavaScript is going to automatically add a semicolon here for us. So as long as we keep our code organized with line breaks and whitespace, we don't need a semicolon here. Now, I do want to let you know that this is just my personal subjective opinion. In the JavaScript community, this is one of the most hotly debated arguments of all time. The debate of whether we should include a semicolon here or not. Now again, if our code is squished together on a single line, there is no debate. We flat out need a semicolon here or JavaScript cannot make sense of what we're trying to do. The debate is if we stay organized with whitespace and line breaks, do we omit the semicolon here and let JavaScript's automatic semicolon insertion do its job, or do we manually include the semicolons? Now, I don't want to brainwash you and tell you to never use semicolons. I'm just letting you know that that's my personal preference, so you're not going to see me use semicolons in the course. Okay, now that's actually going to bring this lesson to a close. In our next lesson, day 10, the finale of this first chapter, we are going to finally build something practical and concrete. We are going to use the web browser's objects and vocabulary or lingo to build a simple to-do list web application. This is going to leverage everything we've learned so far in the course. It should be a lot of fun and something that you can show to your friends and family. So let's keep things rolling, and I will see you in the next lesson. The 10 Days of JavaScript is the first chapter for my upcoming premium course, Full Stack JavaScript from Scratch. I'm making these first 10 or 11 videos freely available on YouTube, and so for the next 10 days, I'm going to upload one new video each day. So stay tuned, or if you're watching this in the future, all the lessons are up, so feel free to binge watch. The full premium course is not available just yet, but if you subscribe to this channel, you'll be notified as soon as it's out. Or if you're watching this video in the future, it's already available. Enjoy!